Okay, we have very, very special guest today. Rishabh Mehrota is industry-known expert and community voice about recommendation system. We had amazing partnership in recommendation team. He was helping us to review our agenda and give us actionable insights. But hey, we knew Rishabh even before that. And I'm following Rishabh personally for a very long time, and I'm very excited about all the work you're doing in research, in community, and in industry. Thank you for that. And we're excited to have you as external speaker today at Kintandar.
Great, thanks so much, Tanya. And yeah, I mean, the pleasure goes both directions. I've had a lot of very interesting conversations with Tanya and the team, a lot of learnings. I started up last year, so I had a few customer discovery conversations as well, trying to kind of get feedback from the team and Tanya around what we're building. So yeah, I'm Rishabh. Today we're going to talk about a bit of RecSys, a bit of LLMs, but I think like the main point for me today is like just give an overview of the journey and how companies evolve from one solutions to a better sophisticated solution. And in the process, like give a view of like, hey, if you think you're working on this problem right now, let's just contextualize it, right? You got to solve 5 of the problems in the next 1 year. So we're trying to go a bit wider, then go a bit deeper on a couple of those solutions, and then see where we land. Typical of me, I have 120 slides and 40 minutes to go through them. So you're going to see a lot of this rushed. But in the meantime, I'm going to pause. Mostly it won't feel rushed. But if it does, then like I can't help it because that's just like how I speak. Quick background. I recently started up Power AI, which is agents for ML work. Previously, up until last year, I was head of AI at Sourcegraph. Sourcegraph was developing coding assistants similar to GitHub Copilot, Cursor. I spent 6 years at Spotify doing recommendations, and my early background was I did a PhD in machine learning search. Joint work with a lot of people like Spotify, Netflix, ShareChat, Sourcegraph, all over the place essentially. So yeah, so we're going to talk about like 3 things. One is let's take a step back and how is the industry thinking about recommendation and search systems, right? So we're going to spend like 20 minutes talking about that, how the things have evolved over the last 20 years and where people are today. I'm then going to use the same background to draw parallels between how people are doing agents and LLM specific context today and draw parallels there. And towards the end, I'm going to talk about like, hey, how do you really kind of take a bird's eye view and map the changes? And this is going to be interesting. I hope this is interesting for both the individual contributors, but also the leaders in the room, because both should acknowledge that, look, there's a journey we are on together, and we have to keep the journey in mind as and when we kind of dive into specifics. So that's the overall goal. Would love feedback if you disagree, if this is resonating well, and all that, right? Cool. 10 minutes on RecSys formulation. So here is where the industry has gone into. Right? If you're designing a new search system, if you're designing a new recommendation system, then the easiest thing you can do is like just have a single retriever and show content to the users, right? So we start from single retrievers, deploy that, ship it, see what works, and then we realize, oh, it's not good enough. Then let's go to a 2-stage ranking system. From that 2-stage, you then it's like, hey, this is good, but how do we improve it? Then you go to like, let's focus on objectives, let's focus on rewards. Once you crack that, then you think about, oh, I mean, it's not just a user I have to keep happy. Let's make more money. Let's make more money for the stakeholders, for the suppliers. And I mean, for example, you guys will care about like, oh, which rental units are getting attention versus not. So you care about other goals as well. And overall, you start caring about the system. So in the next 10 minutes, we're going to talk about how this evolution happens and just give you 1 or 2 examples around them. So if we just start with retrievers, right? So again, I mean, if age-old problem, if you look at Spotify has close to 100 million music tracks. So to recommend to fetch the right items to show to users, I'll have to do a bit of understanding on like, hey, I mean, how much catalog there is, and can I recommend the top 10 music to you? If you look at Netflix, the content catalog is fairly smaller. Like it's not 100 million, maybe it's like 100,000. But then like a smaller catalog, it still means a lot of very interesting problems for us to address. If you look at Instagram, TikTok, Reels, all of these have like 100 million items a month. So the amount of content heterogeneity on these platforms is very interesting, right? Because some platforms will have a lot more items than the others. And the kind of problems you face across them are going to be unique as well. What that means is the scope for discovery is different, right? I mean, like in terms of music, for example, right? I mean, you have 100 million items to show from. In terms of short videos, you have 100 million a month. So then the amount of discovery people can do is different. The user investment is also different, because if you're looking at Netflix, you're going to spend like 2 hours. If you are looking at Spotify music, you're gonna look at maybe 1 or 2 songs for like 2-3 minutes. But then the amount of investment it takes for TikTok is just 15-30 seconds, right? What that means is the number of shots I have at success are very different. If you spend 5 minutes on a platform, and if I'm TikTok, then I get to show you 15 items. Even if I screw up 5 of them, it's okay. I mean, like, I have the chance of learning very quickly on the fly. But then if you are a prop tech company, I don't have chances of showing you 15 items, right? If I don't do a good job at first 5 items and you don't click and like find a rental which is useful, then maybe I've lost the session and the user entirely. So again, this is the differences in how many shots you get. That also gives the scope for feedback loops, right? How much in-session personalization can I do? If I'm Netflix, then I don't have to really worry about in-session personalization. If I'm TikTok, then I really have to worry a lot about real-time personalization. Because within the first 2 minutes, you're gonna give me 7 different signals, and then can I learn from that and quickly optimize and personalize? So then the feedback loop at TikTok is going to be much, much faster than the feedback loop at Netflix. The content reconsumption behaviors are different, right? I mean, I will reconsume a lot of music. I have family music. I mean, the best songs I listen to are going to be, I mean, I'm going to listen to it 100 times a month, probably. But then content reconsumption on short videos is not so much. Now, content reconsumption for your platform would mean that the user is finding these things interesting, right? I mean, maybe there is something about these properties which user keeps getting back to. What does that mean? Maybe this is something I could learn from. But it's still the case that I go back and revisit that rental property 5 times, I still don't make an offer. So maybe it is good, it's not good enough for me to convert. So then like content reconsumption can start giving me some signals about user behavior. Now, most importantly, beyond just modeling, the system complexity needed to build this off is going to be very different. Because if you have to do real-time machine learning, then the real-time embeddings, the real-time systems, in-session personalization, all of these are very, very hard engineering systems to build. So it's not just about the models, it's also about the complexity needed to make this happen. So again, right, I mean, taking a step back, what is the recommendation challenge, right? Essentially, it's like you have a user, have pieces of content, just understanding whether the user will like this content or not, right? Of course, everybody in the room knows this. Now, if I were to start with a single retriever, right, then what could I do? So at Spotify, what we did was we ended up with like an embedding model that you have a bunch of playlists. Can I embed the playlists and music tracks and artists together? And if I have these embeddings give me a way to represent content, right? Now, I have a few choices here. Now, in today's world, should I look at a pre-trained model and extract embeddings? Should I pick up a pre-trained model from Hugging Face, maybe fine-tune it on my data? Or do I learn a new embedding model in itself? Right? So even if I have to use embeddings, I have a few design choices to make right away. Should I just pick up the off-the-shelf model? Is it good enough? Maybe not. Can I fine-tune a little, or can I learn it from scratch? So I think this is where, depending on the stage of the company, most likely we'll end up with like starting with pre-trained models, maybe fine-tuning a bit. But then if you're Spotify, you really want to learn your own embedding models. But then if you're not Spotify, if you're not there in terms of the ML teams, ML sizes, then maybe not. Then what you do is like once you have the embedding model, you can extract embeddings of items and users and do a similarity, and that'll give you a top K. Right? There's no learning happening outside. If these top K items are bad, then tomorrow you still take that decision. There's no learning. The embeddings won't get updated. Users still see the top K from previous. So there's no feedback loop here yet. But this is a good retriever to start with. Now, what people did was they said that, hey, I mean, this is great. I mean, the embeddings are great. Now, can I do some matrix factorization style setup as well? So then people started coming up with these mixed models. And they do a bit of like collaborative filtering with embeddings. And they try to bring the benefit of both the embeddings and matrix factorization earlier. But most importantly, I think this is where the industry is at today, at least some of these companies. They're using a mix of factorization machines to give embeddings. Now, here's my take. I think like we were talking with Peter and the team around this as well earlier, that a lot I've seen in the industry, especially in like Asian companies, is they default to factorization machine models as their retrieval mechanisms. And the reason why is that factorization machines can just take an input of user, item, and label, and then learn embeddings automatically from them. So a lot of the headache of featureization is now left to the models. Why does it work? Is because China, India have like what, billions of users. So these platforms have a lot more engagement data to play with. So then they can pull off really good models by just using factorization machines. So this is very different than embeddings, right? Embeddings, you need a lot of data for the model to learn good embeddings. Factorization machines can work pretty well here as well. So there's a paper on at RecSys 2024, which is around like low rank factorization machines, which is a very, very specific form of factorization machines. Now taking a step back, right? What is happening so far? So far, what has happened is like we have said that, look, I just want to start with a simple embedding model, right? I mean, I want to have a retriever. There's no learning. There's no ranking. I have a few choices. I can either do embeddings or I can do a factorization machines model. I'll pick up one of them and start using them. Great. Then the journey becomes, once you've extracted enough juice from them, then they're like, hey, it's not good enough. Let me then mature to the next version. The next version is a two-stage setup, wherein you have a huge corpus, and then you have many candidate generators. The candidate generators make you go from 100 million items to a few hundred, and then the ranker comes in. The ranker can rank 1,000 items really well, but ranker cannot work on 1,000,000 items because ranker is like very heavy, right? I mean, it's a very sophisticated model. It needs a bunch of features. It can only work on a small number of items. But we want the candidate generator to work on the millions of items I have. So then this becomes the two-stage setup we go to, right? That hey, instead of one candidate generator, let's have 5 of them. One example could be, what are the most popular music tracks? What are the tracks wherein we make the most money? What are the tracks wherein we have a promotional deal with the supplier, right? Maybe somebody's offering us a 5% discount on a deal, and then great, I want to recommend that as well. So those are the logic of the candidate generators. You can have 5 of them, 20 of them. TikTok probably has like 25, 30 of them. Reels always have like 20 plus. Twitter in 2022 had at least 10 plus candidate generators. The reason why I mention these numbers is because most of these industry systems today have many, many, many candidate generators, because each candidate generator brings in some view into the system. Imagine I'm a product manager. I care about making more money from the promotions. So then I will only get one candidate generator, which is promotions based. So that candidate generator only brings in the promotional items to the ranker. So this is where like the two-stage setup goes, right? I mean, tens of millions to a few hundred, which can rank, and then we show 10 to the user. Now, if we take a step back, right, then I mentioned, right, you can have at least 10 or so candidate generators. So which one should they be? So this is the wild west of candidate generator. People start with two-tower models. Twitter, Meta, Reels, all of them have some form of Pinterest. All of them have some sort of like two-tower candidate generator. People also have like factorization machines. I mean, at Spotify, we had create affinity-based, tag affinity-based. And these are just like, you can define affinity however. Like some likeness of the user with a genre, you can define that. Instagram had this account similarity-based candidate generator. That for this user, what are the similar users based on the account you're interested in? And based on that, I can generate a few candidates. A lot of business needs give you candidate generators. Like, I want fresh content. Do I have fresh content in the platform? No. Then let's add a feature. Trending content, maybe revenue margin, maybe tail creators. I want to focus on the tail. One example is like, if you want more attention on a bunch of other rental properties on your platform, then you have to make sure that you have enough tail of these properties represented in the CG land as well. So here's a summary of like, a few different approaches people have been trying on candidate generators. Now, once you have these candidate generators, taking a step back, right? You can have 1 or 2 or 5 or 10 or 20 of them. You still have to rank them, right? So then let's talk about what are people doing in the ranking side. People today in the ranking side are in one of two camps. One is either you have a mixture of experts model, and this mixture of expert model says that, can I make multiple predictions, right? If you're let's say YouTube, right? You want to predict whether the user will like this content, whether the user will save it, download it for later, whether they will complete the entire video or not, whether they're going to add a comment on it or not. So there are 3-4 engagement signals possible here. And then you want a model to kind of learn them and exploit them, right? So So there's a version of the world wherein people care about multiple signals on their feed, and you want the model to learn them. Now, this is also an example from Kuaishou, right? Kuaishou is a China-based short video platform. They have like close to 500 million plus monthly active users, insane scale, and they also have like a mixture of expert model deploying it. So YouTube has it, Kuaishou has it, a bunch of other companies have it. Now, if you're not doing that, then Spotify, for example, has a contextual bandit model. So contextual bandit model is like step one RL, and they decide that, hey, how do we balance exploration, exploitation? Again, we're not going to go into specific details, but essentially you decide on, can I come up with a probability of selecting this particular item, and then develop my recommendation around that. So here what people do is like they try to balance explore, exploit. Explore would be, I maybe don't know enough about you, so maybe I can recommend you some rock music and see, did you like rock music? If you like, great, let me learn about that. If you didn't like rock music, then maybe I learned you didn't like it, so next time I shouldn't. So this is exploration. Exploitation is, here's what I know about you, let me keep showing you that content. So I know you like pop music, amazing, great. Let me just kind of double down and show you pop music. So I think like bandits allow you to balance this like explore versus exploit property really well. The way we did that at Spotify was we started creating these rectangular grids based on this explore exploit. That I'm going to select one playlist to show, and then based on that, I'm going to select the next one, and then I start creating the feed for you one by one. Taking a step back, right? I mean, where are we right now? We have said that you can have a few retrievers. If you're starting a new recommendation company today, you will start with a very simple retriever, which is let's just use embeddings, or let's just use popularity items and add it. 3 months later, you will have many, many retrievers, maybe at least 2 or 3 of them. One of them could be models, 2 of them could be heuristic, right? One, maybe the VP of product says, no, I care about this content. Let's make sure we have it as well. So then it's a business metric informed CG. You have multiple CGs, you now want to rank them together. If you want to be state of the art, then you will pick up either a mixture of expert model or a bandit model, or even like a simple prediction model, and then combine them together, right? So then you'll have many candidate generators and a ranker. You'll deploy that, you'll get some great gains. Imagine you spend like 12 to 15 months getting to this point. What next? What next is you start worrying a lot about, great, I have these models, they're doing something, they've given me gains. Now I want to extract more gains from them. The question then becomes, what should I change? Right? So a checkpoint over here. What you've done, what your team has done over the last year and a half is they've developed maybe 2 or 3 retrievers, and they've added a ranker on top. And it's working great, right? I mean, you've gotten some promotions, you've gotten some good metric movements, amazing. The question then is like, okay, what else should I change now to get the next set of wins? Then you start thinking a lot more about how are these systems actually learning, right? So then you start focusing on the objectives, you start focusing on the rewards, on the signals. Let's look at that example now. So at Spotify in 2019, 2020, what we had was these systems were trained based on this reward. That what is a +1? If you spend more than 30 seconds on the app, great, I love it. Versus if you spend less than 30 seconds, man, not good enough, -1. This is what Spotify production model was up until a point. This is exactly very similar to how Pinterest did it, very, very similar to how YouTube also did it. Here's why. Look, why do I care about 30 seconds? I don't. I mean, if you look at sleep music, a reward of 30 seconds for sleep music is very, very crappy, right? Of course, I mean, if people are listening to sleep music, I want them to listen to sleep music for 30 minutes. 30 seconds is a very, very bad signal. So why do I have the same reward for sleep music versus pop music versus hip hop? No, that's stupid. Same, if you look at YouTube, right? YouTube has a lot of short videos, a lot of long videos. Success for short videos is very different than success for long videos. In the first version of the model, we had the same definition, right? So I have variation across content. I have variation across users. Jazz listeners listen to music far longer than average listeners. So why am I measuring them with the same yardstick? I shouldn't. Probably what I should do is I should do a distribution-based reward. That, hey, let's look at content. Let's look at users. Let them decide what is good enough for them. So this is personalization, right? You're holding content to different bars based on their properties. Ideally, I mean, right now you have this, right? You haven't thought about signals, labels at all. For every user, every content, you have the same function. Great. This is suboptimal. Ideally, you want to do this. Hey, for each user, for each content, I want a reward signal. But that's too granular, right? I mean, it's too sparse, too noisy, too much details. Maybe something in between. Let's group them together. Let's groups, user groups, and let's have content groups, and then see, hey, where are the patterns at? That's exactly what we did. We said, hey, let's do co-clustering, right? Users, playlists, can I co-cluster them together? Now, co-clustering is, again, a 20-year-old problem. Now there are these like scalable, approximate SVD style solutions which can work on top of 400 million user matrices, right? Huge matrix of 400 million users, 100 million items, and then you co-cluster them together. That co-cluster gives me groups of users and content items. And now based on that group, I can decide like, hey, what is my reward signal? Now, here, I also don't have to go as many granular. I can pick up the top 5 groups, and then for the rest, 80% of content, I can have the same function, right? So I don't have to do a very, very detailed job. Just for a few groups of users and items, I can do a specific function. For the remaining, I'll just use what I had before, right? 30 seconds. Now you do that, you get gains, right? I mean, if your reward signal is user aware, content aware, co-clustering aware, you're gonna get better and better performance. Now this is, again, taking a step back. You're not thinking about this in year 1 of your company, right? You're thinking about this when you have multiple CGs, you have a ranker, and now you want to extract the gain. If you don't have multiple CGs, if you're thinking about this too much, then hey, you don't deserve to talk about this problem right now. Go and add the ranker, go and add multiple CGs, and then let's talk about this. Now, another example, right? Let's talk about what signal to optimize. If you look at YouTube, same, TikTok, YouTube, share chat, we have the problem. What should the successful video play definition be? Right? I mean, in YouTube, we have like short videos, long videos, really long videos. Same, TikTok, Instagram, you have multiple videos are short, longer, and all. Now, there you start observing that, hey, part of my content is really long, 5 minutes plus. Part of it is like very short. Part of it is like medium. Now, one definition, how do I even define the successful video play signal to train a ranker, to train a candidate generator, and all that? One definition I could have it, hey, let's have a fixed watch time. If you stream content for 20 seconds or more, great, success. Similar to the Spotify 30-second threshold. The problem is this penalizes short videos a lot longer. Why? Because if it's a podcast, a 1-hour podcast, of course you're going to stream 20 seconds. So on the other hand, what I could say is like, hey, let's do a P50 or a P90, right? That you have to watch 90% of the video for me to give you a +1. Now, P90 is going to be really hard for long content, right? Because a lot of short videos will easily get P90 right. But a lot of long videos will find it very hard to get the P90 right. Because for a 2-hour podcast, you'll have to listen to 100 minutes of it for it to get a +1. For a 20-second video, you'll have to listen to like 18 seconds to get a +1. So now your training data is a lot of short video +1s. Long videos are always -1s. And now your ranker learns, oh, I got to recommend short content. And that's bad because suddenly your entire content distribution is more about short versus long. You can ideally, you should have like a mix of watch time, percentile, and a bunch of those, right? Now, what's my point here? My point is take a look at your content. Think about like, hey, if you pick up this label, suddenly if you pick up one of these labels, your ranker will start showing a lot of long videos. If you pick up the other signal, your ranker will start showing a lot of short videos. And you really care about this. Why? Because share chat, Instagram, they make a lot of money from ads in long videos. Because advertisers wants to pay more money that, hey, if somebody's 15 minutes in a session, I'll show an ad there, then they would want to click on the ad and complete it and not skip it because they have to get to the 16-minute video. So advertisers pay you more money for getting placed in a longer video. Suddenly, if your engineer decided, hey, I'm going to pick up one of these signals, and the amount of long videos on the platform reduces, you start losing ad money just on that. Now, the engineer working on this has no clue that what they are deciding is shaping the content gets shown on the platform, and your leadership cares about the money being made, and that gets impacted. But it's all related. So there, like we did some work on finding out some functions of watch time, watch percentile, trained FFM models for that, and then it was great. So say, I mean, if you don't care about, if you don't pay great attention, then either short videos or long videos are going to overpopulate your content. And this will impact categories, right? I mean, for example, news. When we switch definitions, like a lot of news started popping up more than not, right? So again, different content will get impacted differently. What's the point? The point is defining the label is such an important part. It's just a +1, -1 in your table. That's it. But that really dictates what happens at the company level on the platform and how much money is the company really making or not. It's a very, very harmless looking decision which one engineer took 3 years ago. And we never look back ever at it. But then just changing that suddenly means you're either making less money or more money, and the leadership would really care about that. So it's as harmless a decision like this, and we should be paying attention, is what I'm after. Great. Taking a step back, what has happened so far? You've had a few retrievers, you've had a ranker. Now you're like 18 months into the ML journey. You're like, hey, let me think deeply about my signals. I've done that. Once you do that, then you're like, great, what next? You're like, great, let's make more money, right? I mean, let's look at use. I mean, let's make more money should always be the top thing which you all care about, which we all should care about. Because at the end of the day, if you make more money for the company, great, you get promoted, your leaders get promoted, everybody is richer. But here it's more like, yeah, I mean, I have multiple goals, care about discovery, care about user engagement. I also care about promotional content. I also care about like middle tier of artists, a bunch of these, right? Which is exactly where it comes through, right? I mean, I have multiple stakeholders on the platform. I got to be multi-objective, right? I mean, the way to be multi-objective could be as shitty as weighted sum, right? Huge respect for weighted sum because they really give me as a leader a lot of levers to play around, right? It's fine if you have a very, very crappy ranker. I would rather have some weighted sum so that I can play around with weights and like high leverage, right? At the end of the day, you want high leverage levers inside your stack so that you can make big things happen. And then you need like good models to support those high levers. So what's my point? My point is let's get to a multi-objective world. Let's try to make more money. And then at one point your systems will fail you, right? You want to show promotion content to this set of users that you're not able to execute on that well, and then you go back and change the ranker. Then you go back and change the CG. But then trying to prematurely change the CG without having enough levers, I think you're not gonna deliver a lot more value to the leadership. So there, I mean, we had a specific way of like doing multi-objective, which was if this is where we are, let's say, right? I mean, on the right is my production system. I'm really doing well on objective 3, not so much on objective 1. Can I distribute? So then you take from the rich, give to the poor, right? So this is where it's a pigeon delta principle. Let's do a gap diminishing transfer. Objective 3 is really rich. Objective 2 and 1 are not so much. So then let me pay a slightly more attention. Less on objective 3, more on objective 2, and this will be a bit more balanced, right? So now this is where like it's a 40-year-old function that a gap diminishing transfer from somebody with more with somebody with less will decrease inequality, right? Great. There's an exact function which does that, right? This function has the property that if you pass in these 3 numbers for this function versus pass in these 3 numbers, this value will be higher, right? Because it says that, hey, if there's a great imbalance, I'm going to give you a low score. Suddenly, if I know this function, I just have to put it in my objective, right? I was optimizing for something. Now I'm just optimizing for this function. And because this function has this ability of balancing between objectives, it's going to do a good job at balancing. I've conveniently skipped details of like, hey, everything else. Imagine you have a bandit. Imagine like you're doing this. But then the core point is there are functions which give you what you want. The problem today is not implementing this function. If I go to ChatGPT today and I ask that, hey, can you code up this Gini index bandit? It will write the code for you. It will be 90% correct. The problem is needing it in your production system, right? Even if you don't want a fancy bandit, some of this can be pulled off with great weight sums as well, right? The problem is not this math. The problem is, are we there in terms of leveraging it in my company? Are the leaders there? Are we thinking about these things? If you are, then there's probably like a very hacky way of getting this deployed in this week in your systems. That's too much of a stretch, but just to make the point, right? I mean, this is where we wanted to get to, right? It's not necessarily a zero-sum game. You can get gains in the other objectives without user-centric losses. The point is, do you want it enough, right? And do you realize that, hey, this is what I have to care about in this quarter? So as long as that is the goal, then you can backtrack your way into like getting the OKRs, getting the engineers to work on those problems. I mean, there's a lot of nuanced science problems around that, right? I mean, one example is if you have a multi-objective system and users abandoned, right? I mean, something went wrong. The question is now, who do you blame? Which stakeholders to be blamed? How do we attribute dissatisfaction? What is the feedback loop around? How do we handle spillover across stakeholders? There are n number of science problems which pop up here. But the question is like, should I care about these science problems? Yes, because they help you make more money, right? So it's like if you're doing this, right? If you're doing all this multi-objective, but just to increase user engagement, maybe not so much. But if one of these objectives is like real money, then that's a great motivation for me to tell my leaders that, look, I do all this not because I care about good ML. I care about because if I do this right, I'm going to make you 2% more money at the end of the day, at the end of 2 quarters, 3 quarters down the line. So there, the incentive alignment between the leadership and the engineering and the science work is there. I can do the exact same science, but for user engagement. That won't excite the leadership too much. But if I put in a revenue figure there, then they all care about, oh, hey, have you solved this problem yet? Why? Because it will make them 2% more money, right? So how do I bridge the gap between the leadership goals versus my engineering goals and the science goals? I think good leaders will find a way to do that. So, and then it's about the systems, right? I mean, if where are we, right? We said that, hey, let's start with retrievers. Let's have a 2-stage ranking set up. Let's do some reward, do multi-objective. And then it's about the system has to exist, right? You'll start with some sort of balancing models. 6 months down, you'll say, oh, I need intent models. I need to understand user intent to do this right. Great. I need to do in-session personalization. Great. I need to have a feedback loop. I need to have reward models. I need to have adaptive decisioning. I need to have measurement. So it's a never-ending game, right? You cannot have enough engineers. You cannot. We're not going out of work. Even if like LLM assistants are great at helping, there's enough system complexity to be built in to have a robust system which really makes the company richer from it all. So that's what a mature production RecSys stack would look like X years after ML investments, right? Now I'm way too late on this. This was supposed to be 10-ish minutes. I'm going to quickly rush through the RAG system now, right? So this is what search and RecSys have been doing for the last 15, 20 years. Now, my point in the next few slides are, this is exactly what the LLM context should be thinking about as well. So if you have been a great search engineer, RecSys engineer, you can be a great LLM engineer as well. You just have to draw parallels. So imagine, right? I mean, what does context engine for LLM look like? Hey, I'm writing this code. Then what are the relevant code snippets? So now you're doing like search, but for the LLM. You're not searching for user needs, information needs, and all. You're searching for code so the LLM can answer the question correctly. The question is, hey, how do I ask prefix add and completion, right? So then we bring in the right context. This is what Cursor, Cody, all of these products do. The question is, they bring in these items, but we don't know whether any of this is useful or not. Why? Because like maybe context item 1 was relevant, maybe K wasn't relevant. In search, in recommendations, I show these content to users. They either click on it, not click on it. And I get that signal on, hey, is this good, is this not good? And then I can train my ranker, I can train my candidate generators. In LLM context, I don't get this label. And that's one of the biggest context problems we have. You dump all of these as strings to the LLM, and the LLM gives you the right answer or not. You never observe a label for each of these items. And that makes the context engine problem 10x harder. Because we have done this ranking retriever in search and RecSys. The great benefit we had was we always had the right label because the user was giving us a label. Here, the user never sees any of this. LLM absorbs it. LLM gives the answer. And maybe the user gives me feedback on the answer. I never get relevance on each of these items. So how do I even train these models? That's the biggest question which the context engine people will be answering. Now, if you look at like most RAG systems today, 6 months ago, they're like, oh, we're going to create an embedding model and add it to the prompt. Now, we are search and RecSys people. We know this is a 15-year-old search system, right? Today, what we'll do is like, no, I mean, why do you have only one retriever? Why is there no ranker here? Great, I should transition to multi-stage. I've seen that story in the last 15 years. Great, let's do that. Let's have the keyword search, vector embeddings, local editor. You're on VS Code, you have open files, you have like graph-based context. You just start adding more and more and more retrievers. This is exactly what Cursor is doing today. Now, this is not new to us because we have built, literally, I mean, the RecSys in production in your systems are like multi-stage. The question is, hey, why don't you have a ranker right now? Great, let's have that ranker. So my point is, the context engines in the industry are just a rehash of what RecSys systems have been around with important nuances. They don't get the label which we get. So it's harder to train a bunch of these signals. The question then is like, they also have like heterogeneous context sources. Right now, we only have at Spotify, I only had to deal with like music, maybe at best music and podcast. Here, they just have to deal with heterogeneous content, right? You have to rank code. You also have to rank documentation. You have to also rank the Jira issues because you're an LLM agent, right? So then you have to deal with like heterogeneous content sources, whereas in my RecSys, I didn't have to, right? So that's a headache new over here. Now, the last problem, one of the most important one is like evaluation, right? Like I can do component eval, I can do end-to-end eval. This is what the pipeline is in any LLM app out there. You have the user query, user processing, fetch context, rank it, send it to the LLM, and then you post-process, right? Now, you have a lot of evaluation questions. How well is this context source working? Right? I've done embeddings, I've done graph-based, I've done like local editor. Is it good? Is it not good? Then how well am I ranking it? That's another eval. Hey, how well are my prompts crafted? If you look at some of the like Claude models are great at paying attention to top and bottom. Some models are great at paying attention to context in the middle, right? Different LLMs have different attention mechanisms. So then you have to care about how are you ordering these as well, right? If the LLM is really paying attention to the bottom content, then you want to move things to the bottom there. So again, are the prompts crafted well? Are we situating the context well? All of these are LLM prompting problems. Then combine together, how good is my overall context engine? Then combine together, how good is my LLM app doing? All of these are 5 different evaluation problems, and I'll have to care about all of them, right? So I can start with like, how's this working? How's ranking working? How's prompts working? How's overall context working? And then how's overall app working? And these are all like hard 0 to 1 evaluation challenges. Great, I covered a lot of grounds by doing a shittier job at the part 2. I just have one more slide to wrap everything together, and then I'll shut up for questions. So look, this is what's been happening in the search and RecSys industry, right? I mean, if you look at a bunch of companies, every company will be mapped to somewhere here. Same is going to happen with like agents and RAG systems as well. Now, I just want to spend the next 300 seconds in mapping out where I see this evolving, right, essentially. So the question is, if I look at the time on the right and the complexity or the solution or how much money are you making, where are you in your journey as a team, as a company on the y-axis, right? So let's answer this question, who needs what and when? So I'm going to do it from a company maturity perspective, right? I mean, this is just my view. You can remove these boxes and talk about like how big is your ML team, right? Is it 1 people, 10 people, 50 people, 100 people, 150 people? Depending on like the maturity. Anyway, I just use like series A, B, C to define the maturity. Now, if you're a seed company, right, like my startup, right, I can't care about a ranker. I can't care about like A/B testing. I don't even have users, right? I mean, I have maybe like have 100 users. How do you A/B test in 100 users, right? So a seed stage company will have manual data sets, vibe checking evaluation. They'll have simple heuristics. They'll have a single retriever. So that's where, I mean, if you have like one ML engineer in your company and maybe not even that, then this is where you will be. But once you're there, you've matured, then you care about multiple retrievers. You still don't probably have a ranker. You have a personalized heuristics, right? And then you start caring about V1 metrics. Up until now, you're only doing small data sets. And now maybe you can think about A/B testing. 10,000 users, maybe not. You don't care about fancy offline evaluation, counterfactual evaluation, any of that. After a while, you're like, great. I mean, now let me mature. I can have prediction models now. I can have a 2-stage ranker setup. Why? Because I deserve to think about this right now. At this stage, I don't deserve to think about 2-stage and all that, right? And now I can have some discovery metrics, some diversity metrics. Because again, right, the ranker is evolving, the retrievers are evolving, your evaluation is evolving. Once you're later, then you can talk about counterfactuals. Then you care about experimentation agility. Here you have 3 engineers working on the problem. You don't care about experimentation agility. Then you have 50 ML engineers. Then you care about offline-online correlation. You have to start caring about counterfactuals. You have to caring about not just making the user happy. You care about making more money, making more other stakeholders happy, right? So literally from here, you started evolving your retrievers, your rankers, your evaluation. And once you're a public company, then maybe you care about fairness and societal impact, right? I mean, capitalistic world, again, I had a huge argument with the fairness industry. Like, dude, if I'm a Series B company, I don't care about fairness. I don't care about society. I just have to survive as a company. So if you bring in societal fairness in my picture, my leadership is gonna not care, right? But once you're public, then you have to care about long-term impact, fairness, and all those. And then you can maybe do constraint optimization. You have nuanced systems. What's my point? My point is, look, if the early example I showed, right? I mean, you have multiple problems to care about at multiple stages. Depending on how mature the team is, how mature the company is, then somewhere along the spectrum you are. And the learnings would be, oh, I should be doing this right now, versus, oh, this is very, very cool thing, but today I don't deserve to do that. So I think I'm just trying to kind of get that framework around teams deserve to tackle certain problems when they are at certain maturity. And that's exactly how leadership to think about. That's exactly, if I'm an ML engineer, I will read the best evaluation paper on counterfactual evaluation, but hey, maybe it's too early for me to bring it home, right? Maybe my leadership shouldn't care about it today. So this is just a way for me to present this thought for leaders, for engineers across the spectrum. So taking a step back, the take-home messages, and I really appreciate you appreciating the left side of the slide more than the right side, because this is a cool GIF, like take-home messages. So yeah, RecSys formulation, you start with reverse, get to two-stage, start thinking about reward signals, start thinking about multi-objectives, start thinking about systems. The context engines and RAGs very, very easily replicate all the learnings which search and RecSys engineers have. So if you are a RecSys engineer and if you have this FOMO, hey, I'm not working on LLMs, dude, you're working on the best problems today. Everything you do is something which the RAG engineer should be learning from you. So great, no FOMO there. And yeah, I think like companies should mature their formulations as they scale, and the engineering steps needs to scale as the formulation scale as well. So a bunch of references and I think exactly $45. So we did 120 slides. I don't know how much you understood or not, but at least I was able to cover in good time.
Rishabh, before we go to the Q&A part, I keep getting like very nice feedbacks meanwhile in personal chats. So thank you so much for joining us today. And like, let's move to the Q&A section. Who has questions?
I mean, please.
Yes, let me. So first of all, thank you so much, Rishabh, for this great presentation and very insightful presentation. So my first question is like, I heard a lot about two-steps approaches, like the one you mentioned for ranking, and I always wondering. I was willing to have your expertise on that, like, because the ultimate objective we are interested about is the combined effect of both steps, right? So, and how do we, like in practice, how do we deploy this? Like we take advantage of the retrieval model as the first step, or how do we test like individually those steps so the combined effect is actually good?
Yeah, I mean, excellent question. I think one thing which I had to really scramble my head, and I know a lot of companies do that, is what's the CG ranker handshake? Right? You're like, hey, it's not working. Right? I mean, imagine there is a certain types of rental units which never get any attention, and we're losing money there. Now, who should I blame? Should I blame the ranker? Should I blame the CG? Right? The question then is, let's go back and find out. When I find out that, hey, I mean, there's no CG which is bringing that, then I go blame the CG. Now, even if you add the CG, right? Let's say that you add a CG which exactly brings that content. Now, when you ship it, it still doesn't show to the user. Now the question is like, who do I blame? Right? The blame is like, hey, ranker, I'm giving you the items, you're not ranking it enough. Maybe the ranker say, no, you're not good enough, and that's why I'm not ranking you enough. So just acknowledging that we need a CG ranker handshake. What that means is how do you go about trying out a new CG? Most of the companies I've talked with, including Reel's engineer, as of 8 days ago, he mentioned that if I have a new CG, I launch a 1% A/B test without the ranker to show its value. Because tomorrow when I add it to the ranker and ranker will not pick it up, because ranker may not have the features it needs to pay respect to that CG. So then the rankable team will have to add the features. So it's a complicated journey, right? Like I have a CG. If I'm ranker, I'm not going to add features for every CG you can come up with. Like, why should I? You have 10 CGs. I don't even know if any of them are useful. So then go show that value. Go launch a test without the ranker, see that user engagement is slightly better off. That gives you the justification that I should pay any attention to your CG, right? So now the ranker CG handshake looks like, you do some evaluation, great. You launch a test, 1% test without the rankers, show value, and then you make the case for like, hey, here is why I should add the ranker, and then we go from there.
Thanks a lot.
Okay. Actually, I have a few questions, a bit of a different question. So when you were talking about multi-objective optimization, you're talking about optimizing that formula. How do you think that works with longer feedback? For example, we at Quintana typically we have longer feedback. Sometimes it takes 40 days, sometimes it takes 20 days to really understand if we were successful with the user or not. Do you think that type of optimization works well to optimize that weighted some kind of function? Or do you think we could have a bit more issues in that state?
Yeah, no, I think it's a very hard problem, right? Because I think like this is I think like just last week there was a very nice paper from Google on like long-term feedbacks, and like I mean I have it on my WhatsApp. I haven't read it entirely. I can share that, but I think like my expectation from the journey view would be, what's the proxy? Look, first I'll have to prove to my leadership that I can do multi-objective ranking, right? Just weighted sums on a short-term goal. Long-term, forget about it, right? Because like, hey, can I even pull off like short-term? Show that look, here are the 3 things we might care about, and now I have control on my system that if I want to double-click on 2, I can make it happen. And that gives me a great validation that if I have a goal, then I can make that goal happen in my product. So that weighted sum initially will give me that control. At least now I have control over my system. Great. Now let me add a couple of other metrics and show that, hey, that control retains. You start from 0 control to like some control, and then that control transfers to the objectives, and then you start bringing in the proxy short-term win for the long-term thing, right? And then, I mean, then there's another proof needed that, hey, why is this short-term even correlated with long-term? There I can go back and look at a bunch of A/B tests, wherein I was not trying to move this metric, but this metric moved, right? And then even if I do some randomization or past 15 A/B tests, then this short-term proxy would have moved up and down. And can I look back and see that what happened at the 2-month mark of that? Did the long-term metric move up and down? Now, I haven't done anything for this metric, but past data would have, past experiments might have moved things up and down. So then I collect that validation, and I use that to show that this proxy of short-term is useful for long-term. Why? Because, look, I never even ran these tests. Other teams did, and that was useful enough. And once I do that, then start adding this in my short-term thing, right? So I think those are the series of validations which we'll have to do to kind of get there.
Yes. Great. Thanks, Rishabh. Amazing answer. Just a bit of a follow-up maybe on Julia's question, but maybe a bit of a longer one. So let's say that we have maybe a chatbot that's kind of talking with a customer. They're saying, I want a bedroom, I want maybe a lighted kitchen, for example, etc. So there's some back and forth kind of specifying requirements, and then we're showing houses to the user. So my question here, typically we can do that. We're going to have maybe 100 or maybe 1,000 candidates to show the user, but maybe then we want to have some personalization. And so let's say that we already have an existing ranker. Maybe this is a problem in some companies. We already have an existing ranker that we know that works very well, that's personalized and very, very well. But the problem is the ranker doesn't connect directly with the back and forth kind of feedback that the user was saying on the text. But before we have any training data on that, maybe after a lot of logs, maybe then we'll have the training data. But before we have the training data on that, do you have any kind of ideas on how to connect?
Love the problem. Would love to brainstorm on that separately as well. Look, this is amazing, right? Look, I have a ranker. That ranker is not for chatbot consumption, right? But then the question is like the chatbot back and forth can get me a refined query. So my items are still the same. My user query gets defined. Right? So if I've done like 2 back and forths, then I can really formulate a very, very sharp user query, right? I mean, that query is not, I mean, I would say that we should do that for all the non-chat interactions on the app as well, right? It's like, hey, I mean, does the user care about like a balcony? Does the user care about this or not? So I think like the real query which user types in is very under-formulated, right? So query reformulation has been a thing for the last 20 years. That means it's a great thing, right? I mean, +1 on the industry doing that, so we should do that as well. It's just that the chatbot now gives me a very, very rich modularity to do query reformulation because users themselves are writing more English. So then I would reuse the same ranker I had in search and RecSys. It's just that the query is now coming in. It's not directly, but then I can process the conversation and extract a very, very rich query. And now this query need not be an input only to the ranker. I can have the CG as well. Right now, imagine the input to each of these CGs could be another transformation of the same conversation, but now in a world which CG understands.
Okay, thank you. I still have one last question. This might be kind of a more broad question. So we've seen LLMs a lot. We've seen some ideas for LLMs for recommendations where the LLM directly does recommendations. How do you feel overall? How is the LLMs going to overtake like the recommendation world? Do you think they'll take some time? Do you think it'll ever happen? What do you think about that?
Yeah, so I think, I mean, the easy, I mean, two things, right? One is, I would say that regardless of where's the easiest win at, right? I mean, look, I mean, I have a team. I need to deliver to my leadership. I want to get promoted in the next 3 months. So what I would do is like, rather than thinking about like where is it going, like what's the most useful case, shortest win path today, which is like, let's use the LLMs as feature extractors for content, right? So if I look at Reels has shipped LLMs for feature extraction, powering their own internal like RecSys stack, right? So they still have the ranker. Now the ranker is aware of a bunch of features, which is extracting a lot more, right? So it's like great. I mean, the rankers are working, and there's like enough iterations in the industry out there. Here is where, like, I am at level 20 out of 100 in the RecSys maturity stage. In the LLM, companies themselves are at like maybe 5 or 10. Even the best companies are maybe at 20 or 30, right? But then if I have to copy, it's far easy for me to copy the RecSys iteration because I know like there are better solutions. I just have to monkey copy, monkey mimic, and get to 70. And when I get to 70, by the time people will go from 20, 35 in the RecSys ranker, in the LLM ranker anyway. And once I'm at that 70, then I can borrow and switch tracks and go do that, right? Because why should I? It's unnecessarily harder for me to think on what's the best Gen AI ranker is. Like, yeah, I mean, Reels is already doing that. My next win I can get from copying Reels general ranker rather than like Gen AI ranker because they are learning for us, right? So it's like, it's cool to spend time in Gen AI ranker, but then like, hey, I mean, the easiest win for me is let's just copy the next stage of the RecSys ranker they had and eat that win. And once we eat that win, I mean, you can also have a portfolio, right? That I'm going to do 80%, eat the short-term wins so that you deserve the right to go after the fancy, cool problems. And that could be like a good balanced portfolio as well. I mean, I can ask my engineers, go ship that small mini win. And if you do that, then you get 20% bandwidth to go and try like other LLM things as well if you really want that. But I think the shortest answer is, again, after 5 minutes of the answer, the shortest answer is the featureization value, extracting that has been the biggest wins I've seen so far in the industry.
Thanks, Rishabh. Thanks.
Thank you, Rishabh. May I ask you to go to the like evaluation slide, if possible, for a second? Yeah, I just wanted to, I was looking into this slide, and I think it covers perfectly agentic use case because like you're saying that we need like to evaluate each component, and everything together too. But I wanted just to reiterate with you that it really fits agentic use case too.
I mean, +1 on agentic, but even most, look, agents are task. Right. So I think like agents should also have a well-defined boundary of like each task. Each task should be having input, output, and a definition of success for each task. Right. One example is like if I have an agent to write unit test, then the evaluation of unit test generation has to only be about unit test. Like what makes a good unit test versus not, right? You can write a shitty unit test, but then like I'll have to come up with like a specific evaluation on the task which the agents do. What's my point? My point is, so far, in the search and RecSys community, we have been okay with like engagement as an evaluation. Now that is useless in the agentic land because engagement is not what agents are for. Agents are for doing a task for me. And if your agent is doing 3 tasks for me, then I should have an evaluation on these 3 tasks independently. And then I know that, hey, how well are you helping me do that specific task? So I think like my worry, and I was sharing with somebody else as well, on like, hey, I mean, evaluation is hard enough in the industry, in the search RecSys industry. And now with the agentic setup, evaluation explodes. Because if one agent is trying to do 5 tasks, then we need 5 set of evaluations, 5 set of metrics around that. So I think like people who are really good on evaluation, they'll have amazing job opportunities in the new world because agentic evaluation is 10x harder than RecSys. In RecSys, look, I didn't have to innovate. You don't have to innovate on much on like prop tech evaluation. You can borrow what like search and RecSys and like Netflix, Spotify did. But if you're developing an agent for like real estate discussion, then you'll have to do your own homework of evaluation. You cannot borrow something which Netflix did because Netflix agent has a very, very different goal than this agent over here. So I think the evaluation need is going to like blow up. And I don't think like we as an industry have good enough engineers who understand evaluation deep enough to tackle that problem. So great. I mean, what that means is agentic evaluation even harder. I mean, not to scare people, but if you are really good in evaluation, like it's a great world for you out there.
Rishabh, thank you very much for the presentation. It was great. I was thinking about the part that you mentioned that we could use the different retrievers for different business goals, right?
Yeah.
Because I never had this way of thinking here at Kingdom, but I think for our business, we had some opportunities to think about this. For example, sometimes we want to care about like high ticket properties, right? More expensive properties, or we want to emphasize listings that comes from the 3P marketplace, because we started back a while back ago to accept other real estate brokers to make their listings at our search system. Sometimes we want to optimize listings that were rented one time and we were re-renting this property, or whatever, or other kinds of listings that has low demand, that we probably should think about this. So, and the way we were trying to do this before was like trying to tweak the ranking function, or even to like do some boostings of the score to do that. But I never thought about doing this in the retrieval part.
Yeah, and I think that's also because, look, I mean, at the ranker, right? If the retriever is not bringing it, then no matter how much weight I give, it's just ranker's world is constrained based on what the retriever does, right? And if the retriever doesn't give me the space to play with, then I can do as much. Even if I have like AGI and God solve ranking for me, it still won't matter, because the rank is not even getting access to that content. So I think like if you just do weighted sounds and optimize for that without touching the ranker retriever, then it's just like you're putting in a lot of extra hard work unnecessarily, right? It's easier to just add it as a CG and see where because then the leverage you get from your actions is magnified if at least the leftmost part of the stack is at least giving you the chance to act right.
But for assessing this experiment when it's live, we'll probably need to check all these different business perspectives, like these different business goals, but also to check if this is going right in the retrieval part and in the ranking part. Like if the rank is not downgrading things, right?
Exactly. And the most important part is, look, I mean, for the cases you want to make more money, you make that, right? But all the other cases wherein you didn't want to have any impact, you're now making it worse unintentionally, right? So that's the hardest part of multi-objective evaluation. That, look, I mean, I want to get the benefits, but without the cost, right? Because a bunch of 80% of the sessions should be as is, right? It should not be an A/B test for them. It should be an A test. Nothing changed for you. But the thing is, like, exactly, right? So you want to be solving exactly that problem. And that's why, like, forget about the best ranker. Like, just putting a weighted sum, I want to get to that place now rather than 1 year from now. So that what that means is, fine, it's okay to be a suboptimal ranker, suboptimal C, let's do weighted sum. Because the moment I do weighted sum, I can face this problem and then move metrics around that. So that is more leverage ROI for you than like making the CG even better, right? Even a heuristic here, let's just kind of add it, right? So my point is, disrespect the problems too much, because otherwise you'll end up spending 6 months on something which could have been done in like 2 weeks.
Thank you.
Thank you, Rishabh. Like, it was amazing. Thank you for finding time. And if it is possible to share this presentation, it would be amazing.
Yeah, I'll share the presentation as well.
Yeah, we need the links, right? A lot of references. Thank you very much.
Great. Thanks so much, Tanya. I really love the chat. See you guys.
Thank you, Rishabh. See you.
Thank you, Rishabh.
Goodbye.
Thank you.
Don't forget to stop the recording to not lose it.